This topic is on the real numbers. The real numbers are all the rational numbers and all the irrational numbers. So let's look at it this way. One part of the real numbers is the rational numbers. Rational numbers are numbers that can be written as a fraction of two integers. So for example, the decimal 0.5 is a rational number because if you write it as a fraction, this is 5 over 10, which simplifies to 1 over 2, which is a fraction of two integers. The square root of 4 is a number that when multiplied by itself gives you 4. Since 2 multiplied by itself gives you 4, then the square root of 4 is equal to 2, which can be written as 2 over 1, which is a fraction of two integers. And also, negative 0.333 and so on is also a rational number because this is equivalent to negative 1/3, which can be rewritten as negative 1 over positive 3, which is a fraction of two integers. Within the rational numbers, we have a subset which is called the integers. The integers are made up of all positive and negative whole numbers and 0. For example, negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. It continues forever in the positive direction as well as in the negative direction. Within the integers, we have a subset which is called the whole numbers. The whole numbers include 0, 1, 2, 3, and so on. It continues forever in the positive direction. Now let's look at the rest of the real numbers. If a number is not a rational number, it is an irrational number. Irrational numbers cannot be written as a fraction, and when written as a decimal are non-terminating and non-repeating. The irrational numbers include numbers such as pi. Pi is approximately 3.14159 and so on. It is non-terminating and non-repeating. Another example would be the square root of 2. Since there is no nice number that when multiplied by itself is 2, the square root of 2 is irrational. It turns out that the square root of 2 is approximately 1.41421 and so on. It is non-terminating and non-repeating. I used a calculator to approximate the square root of 2, but I didn't need to use the calculator to determine that it was irrational. Now let's look at an example. In example 1, we want to classify each number as an integer, a rational number, an irrational number, and or a real number. So let's start off with the number 8. 8 is an integer, which is also a rational number and a real number. Negative 1/5. Negative 1/5 is not an integer, but it is a rational number because it can be rewritten as negative 1 over positive 5, which is a fraction of two integers. And all rational numbers are also real numbers. The number 1.65 is not an integer, but it is a rational number because we can rewrite it as a fraction 1 and 65 over 100, which can be rewritten as 165 over 100 and simplified to 33 over 20, which is a fraction of two integers. And all rational numbers are also real numbers, so that makes this a real number. The square root of 3. Since there is no nice number that when multiplied by itself gives us 3, that makes the square root of 3 an irrational number. And the square root of 3 is approximately 1.7320508 and so on. Notice that it is non-terminating and non-repeating. Irrational numbers are also real numbers, which makes the square root of 3 a real number. The number 0.444 and so on, this is equivalent to 4 over 9, or 4/9, which is a rational number and also a real number. The square root of 9 is the number that when multiplied by itself gives us 9. Since 3 multiplied by itself gives us 9. That makes square root of 9 an integer, as well as a rational number and a real number. Now we're going to look at the real number line. Any real number can be plotted on the real number line. So here's the real number line with several numbers I plotted on it. Some were rational and some were irrational, and some are integers. Let me show you the numbers that I plotted. The rational numbers I plotted are -3, -2.5, -3/4, 1/3, 1 1/3, and 2.25. Notice that -3 is also an integer. There are also two irrational numbers that I plotted. They are negative square root of 2 and pi. The real number line extends in both directions forever and include both rational and irrational numbers. Let's look at some examples. We want to plot the following real numbers on a real number line. 1. We want to find 1 on the number line and put a dot where the 1 is on the number line. -2.75. This is the same as -2 and 75 over 100, which simplifies to -2 and 3/4. So we want to put a dot between -2 and -3, but closer to -3. 1/2. 1/2 is exactly halfway between 0 and 1, so we'll put a dot there. Now let's look at some different examples using real numbers. Here, we'll use a real number to represent each real-life situation. A temperature of 131.2 degrees Fahrenheit below zero is recorded in Antarctica. Since this is 131.2 degrees below zero, we can represent this as the real number -131.2. The height of a mountain is 22,645 feet above sea level. Since this elevation is above sea level, we can represent this by the real number 22,645. A golfer scored 5 under par in a recent tournament. Since the golfer scored under par, we can represent this by the real number -5. This concludes our video on real numbers.